can't hear me, can you? I can't hear myself. How about now? There we go. That's it. Okay. Yeah, I'm going to be moving around, so the video guy's going to really work for his money with me. So, okay. Let me just make sure everything looks good here. Okay, cool. All right. Well, first off, thank you very much, everybody, for coming out today. It's nice to see so many people here, and I'm hoping that many of you are interested in 3D technologies. For some of you who have been following some of this stuff, you'll know that over the past few years, there's been a huge interest and huge growth in 3D printing. Technologies have been coming out like just one after the other. You know, they've got tablets now with depth sensors. Companies like Google, if you do a search for Google Tango, they've got a phone now that has a depth sensor inside of it. And Apple has purchased 3D technologies, Microsoft, and even Autodesk, right? They've invested a huge amount of money into software that does 3D. So I think it says something about maybe what the masses want and maybe what some of the things hold for the future. So today I'm going to be talking to you about how I use 3D scanning in the forensics field. And it has many, many different types of applications. My background is actually in aerospace engineering, so I graduated from Ryerson downtown, and so sometimes when people speak to me, they're like, hey, how does a guy from aerospace go into forensics? And it was kind of by accident. I don't have a lot of time to talk about it because I'll probably run out of time. There's a lot I want to say, and you'll notice that I'll probably be speeding up as I go along here because I'm going to be rushing to get stuff done. But when I do meet people, it's interesting to note that they're actually very educated on a lot of the technologies for forensic investigations. And when I sort of speak with them, whatever, there's always a question I get asked that's very important to people. And that question is most asked, and somebody asked me today, do you watch CSI? And that, I don't know why that fascinates people, but I think it's because there's just a massive show, you know, just so many shows. So the answer to that question is no, I don't. I hardly watch TV, and when I do, it's not going to be CSI shows. I want to show you just some things, some different just snapshots of what I call 3D forensic reconstructions, which is really what I do. And so this is one that is just obviously a model of a torso. It's a 3D model, and you're seeing some bullet trajectories going through a body. And so this is very convenient and very useful if you're going into court and you're going to be presenting something to a jury. Instead of looking at some maybe grotesque pictures, you can present something like this, and it's sort of familiar. You can kind of understand what's going on. The other thing too is that if you've ever read a medical examiner's report or an autopsy report, the language is a little bit different. So sometimes for the layperson, it's not very easy to understand. So this is another one. This was an exercise that was done with the was International Association of Arson Investigators, and so this was an exercise where a farmer actually donated an old home that he had, and he said, okay, you guys can burn it down as an exercise and go ahead. So I actually scanned this. I laser scanned it before, and I scanned it after. And you can see here, you get to see the just everything, inside, outside. You'll see that in a second here, the roof drops down. And I scanned it afterwards, after the rooms, some different rooms were burned and such. And so it's very telling. A lot of times in forensics, what a lot of agencies do is they map out a crime scene or an accident scene, and they turn it into a 2D drawing, like just a plan drawing, flat. But when you look at something like this, it's a lot more telling. You get the color, you get a better sense of the space that's there. And actually, before I forget, can you grab that for me and just bring it up here? Thanks. Okay, so I'm just going to move on from there. So next one. So here's another one. So this would be something for people, if anybody here is doing accident investigation, same type of thing. You can go and do a 3D survey of a site, and you can model the environment, and then you can do some different things. This is actually a combination of technologies. This is using photogrammetry. This is using 3D documentation, and using a process called camera matching. So if you had a witness that was standing here, and you said, hey, somebody was here, and they say, oh, this is what I saw, you could reconstruct the accident and then basically show the witness, and they say, yeah, that's exactly what I saw, then you probably got it right. So this is another one. This is actually a shooting case that I testified in the US not too long ago. This was a triple homicide case, and it was an Indiana State Trooper who was accused of killing his wife and 2 children. And so it turned out that he was completely innocent. He spent 13 years in prison for it, but they found the guy who actually did it. But I was asked to reconstruct the trajectories, and so I scanned the Bronco, this vehicle, and what you're seeing on the bottom is actually a police total station survey, but a drawing that they did, a flat drawing. And there was a lot more work that I did here, and actually not too long ago this was actually featured on NBC Dateline and CBS 48 Hours. So these are a bunch of things that I do, and over the years I've sort of come to my own definition of what I do. And so 3D forensic reconstructions is a process. And so you need to document, you need to analyze, and you need to visualize the things that you're doing. And what you're trying to do is accurately represent an object, process, data, or an event. So there's kind of a lot there, but if you think about an event, it's something that's time-based. If it's a shooting or if it's an accident, you may be interested in the sequence of events, right, leading up to a certain point, or maybe post-impact or something like that. So it's time-based. That's the key there. Data or a process, that's a little bit more abstract. But let's say, for example, there's a terrorist attack, and there's chemicals, or some kind of chemical that's across a city or something. You might be interested in the chemical concentration laid out geographically, and maybe that will tell you something about the source. Now, objects. So if you have an object, I call an object in here. This is an object. It's just a big scene. It's full of different objects. But a crime scene can be indoors, can be outdoors, can be in a car, can be in a whole number of different places. So you can scan scenes, and that's what people typically think about when they think about a crime scene. But actually, an area that I'm really interested in is scanning little things. Bullet cartridge cases, bullet trajectories, bloodstain patterns, footprints, things like that. So it's something that's not being utilized a lot, but there's an opportunity there to do all kinds of really interesting things in this whole world of forensics. So when you're going to be scanning, there's some different things that you need to take into consideration. And one of them is the size of the object. That can often define what technology you're going to use. Am I going to scan something that's a kilometer wide, or am I talking about something that's a millimeter big? So it makes a big difference. The other one is going to be the form. What's the shape of this object, right? So we just heard about line of sight. Like, can you actually see it? Is it being blocked by something? Well, then you got to get around it. Is it a small, very convoluted part? Maybe you need a hand scanner. Maybe you need a terrestrial scanner or something that's bigger. So you have to take that into consideration. Also, surface finish. Well, if you're using a technology like this that's based on light, then anything that adversely affects light is going to be problematic. Water, glass, mirrors, dark, shiny surfaces, problematic. So maybe you want to think about using something else. And also, of course, the accuracy, right? Do you need centimeter accuracy if you're doing an accident scene or something like that? Or do you need something that's sub-millimeter? You have to consider those things as well. And what about the output? So a lot of people don't think about that, but what you do with the data, or what you're going to do with it on the back end is very important, right? So if I come in here and I say, well, I just want to scan the outline of this auditorium. Well, I could probably take the scanner, drop it down, and just do one quick scan, and I'll get an outline. But then if I'm going to do a full reconstruction or something like that, well, I need to scan in a whole bunch of different places. So it may not define what technology you use, but it does define how you use it. Okay? So now let's talk about technology. And so I have a question for everybody, and I'd like to see a show of hands. I'm going to ask you 2 questions. So I'll ask the first one. How many of you here have with you right now a 3D scanner? Some people are putting their hands up. Okay. And yeah, somebody said he's got glasses or something. I don't know. Okay, their eyes. Well, it's not really your eyes, but you'll see what my next question is. My next question, I'm going to ask it differently. How many of you here have a digital camera, a mobile phone with a camera, a tablet with a camera? And if I don't see everybody put their hand up, man, you're lying. So I know everybody's going to have one of these. So the first thing I'm going to be talking about is photogrammetry. And it's sort of an underutilized technology, but photogrammetry has gained a lot of traction lately because of some of the automation. If you have a digital camera, you have a type of tool that can document things in 3D, and I'll show you some examples in a second. Now, photogrammetry is made up of 3 Greek words. Photos, meaning light or light rays, gramma meaning to write or draw, and metron meaning to measure. So you have a light drawing, which is a photograph, and metron to measure. So photogrammetry is really just being able to measure from photographs. Now, some of the things, traditionally it's been used for like aerial surveying and things like that, but some of the newer modules and such of photogrammetry allow you to produce things that are really, really defined, high definition, really good quality models. So this is a model of a skull here, and on the left you'll see I've got a whole bunch of different photographs that were taken with just a standard digital camera. And on the right there, I had a model of a skull. And so I'm just going to bring this up here, and I'm going to show you sort of what it looks like. And this is actually a reduced version, but you get the idea. You get some really, really good quality results here. You see the sutures, you see a lot of it's got really nice color and texture. And so now this is, can be extremely useful. Let's say, for example, you want to take something like this and produce a 3D print. Well, now a facial reconstructionist can use the replica as opposed to the real skull to create a facial reconstruction. Right? So there's a number of things you can do with something like this. If you want to use this for ancestry, there's a number of different things that you can do once you got the 3D model. All right, so here's another example. So people that are doing roadway stuff. Let's say, for example, you have a tire tread and there's something lodged in there. Let's say it's a case where you can have a bullet cartridge case that's stuck in a tire. Well, again, this was done with photographs, just using a standard digital camera and software. And you can see that I have very, very high resolution in this particular model. What I'll do is I'll turn on the wireframe, and so you can see the underlying mesh that's here. And it's a very high quality mesh, right? It's extremely powerful what you can do with just a digital camera. All right, so I show this picture. This is from the field school at the University of Toronto. Actually, I just noticed it says University of Toronto. I just teach one course there, so it's not really my main thing. But I teach a course in the Forensic Sciences program. And this is from a field school at the, I believe this was the Forensic Anthropology Field School. And what they're doing there is that they're practicing their skills at excavating a clandestine grave. And so traditionally, when people take measurements, what they'll do is they'll first document, let's say, the top layer, then they'll go down, they'll find a piece of evidence, then they'll document again, they go down a bit more, and they do this in layers. So what you're seeing here is 5 people taking one 3D measurement, and they're holding lines and levels and stuff like that, and then somebody holds a plumb bob and takes a measurement. So it's a very, and there's one person recording the data as it's called out. So it's a very tedious process, right? So when you do this with 3D, and this is sort of how I got into the whole university thing, was I showed up and I spoke with the director, and I said, well, let me show you what I can do. So after about 2 minutes of taking photographs, I was able to produce my own model. And the model wasn't just one point, it was millions and millions of points, and it looks something like this. So this was actually from a class exercise that we did, but I think you get the point. Very high definition, lots of information here that you can use, and you can even make out the tool marks here up on the side, right? From the shovel that actually that made these marks. So you can use it for matching tools and such. And if I were to take photos that were even closer, I would get higher resolution and better quality models. Okay, let's move on to another technology. I'm going to talk to you about structured light scanners. So there's sort of 2 types of scanners. And one, I would say, this is the way I classify them. One is stationary. As it's scanning, it stays still. And the other one is handheld. So you actually have to move it in order to pick up the scan of that particular object. On some of the handheld scanners, you can actually rotate the object, but they're really intended for you to sort of walk around. And they're very useful because if you have something where you're trying to get underneath, you can take the handheld scanner, move it underneath, and move it to different areas. So for crime scenes, and if there's a body on the ground or if there's evidence that you want to document, it's very useful because you can capture very quickly. Now, the way that these things works is that they emit a pattern, okay? That's why they're called structured light. And it's usually a fringe pattern, something like this. And so by dividing, by creating all these patterns and by triangulating in, they can actually pick up a 3D point for any pixel, let's say, that's on that the camera can pick up. And they make very, very compelling models. The other benefit of these things is that they're very fast. So I'll show you what a pattern looks like. And it's about something like that. So within that amount of time, you've actually documented the one scan. So it's really, really quick. So what do these models typically look like? Well, here's one here. I'll show you this one. And so, very useful. So let's say for documenting footprints. If you have a suspect and he has a particular shoe and you want to match it to a print, you can do something like this. So you've got the tread, you can take measurements from this, right? You can calculate the wear, how much wear was there, and you can look at a footprint and make some kind of a comparison. So if on that theme, if I can scan a suspect's shoe and then I can scan a footprint, then you can make a comparison. And traditionally what they would do is take a photograph. You take a flat photograph of the sole, you take a flat photograph of the print. And traditionally you shoot at 90 degrees to the print. But what are you doing when you take a photograph? You're taking something that has this 3D profile in it and you're plastering it on a 2D sensor. So you're removing depth. You're losing that depth information, which may be very characteristic. It may give you a very, very specific signature. So with 3D, what you can do is take these two, put them together, and then put them in software and say, hey, show me all the areas that are within 0.5 millimeter of each other. And bang, you get this image in front of you that's colored. Now, if you take this and put this in front of a jury and say, all these areas that are colored here are within whatever, 0.25 millimeters or something like that. This is a very compelling piece of evidence now. Fingerprints. So I show this one out of interest. This is a unit here that is actually scanning your finger. Now, you don't press your finger against the glass. You hold it above it, and it's a structured light scanner. It actually emits those little fringe patterns. So you get these stripe banding on the finger, and then it creates a model of your finger. So now if you have a suspect, you can actually document the fingerprint. So, and you can also, sorry, I'm just grabbing something here. You can also make up a 3D print. So this is not from a really big person. This is a scaled up model of somebody's finger, right? But you can imagine, this is something that I don't know has ever been done, but if you're a latent print examiner and you're in court and you're trying to match fingerprints, you typically do that on a flat piece of paper and you show a chart and show some matches. But now you can give this to somebody. You can mark things and you can say, hey, look, these are the points or the parts of the finger that were matched with a print that was found at a crime scene, right? And now somebody can take this and feel it, and you can actually feel the ridges. Feel the ridges on the finger. So for people who learn through tactile feel and touch, it's another way to sort of present evidence. Okay, so now I'm going to talk about another type of structured light scanner. Who here has the Microsoft Kinect Xbox? You guys know what that is, right? Okay. So the Xbox Kinect sensor is a 3D depth sensor, is really what it is. And it's a structured light scanner. So what you have here is an infrared projector, and it is projecting a pattern. Now, it doesn't project the fringe pattern. It projects a series of dots. And these dots are structured. So they're not just random points. There's actually a structure to these things. And depending on how those dots deform, it can figure out 3D points. So you also have an RGB camera. You have a regular camera that can project the color information or assign color to that point. And you also have an infrared camera because you need something to see the actual points that are being projected. So I'm going to give you just a quick demo here, and I need some volunteers to do this. Let's see here. How about you three? Can you three come down? Yeah, that'd be fun. Okay. So what I'm going to do is I have a sensor here, and it's the same technology. The same people that made the technology for Microsoft is a company called PrimeSense. And so this is an ASUS. It's called the Exion, and I don't think they even make these anymore. But it's something that's pretty low cost, and it's kind of given to people as a development thing. So what I want you to do now is actually come here. If you just stand in front of me and just face me here, you stand behind or beside her, and you two, you stand over here. Okay, and just face me. Don't worry, this won't hurt one bit, trust me. Okay, actually, I'll tell you what, make this easier for me. Can you stand right here? Come closer to me. Okay, now you're seeing it's actually starting to sense depth. Okay, now here's the thing. You gotta stay very, very still. Okay, so that's the thing. So you can't move, because if you move, it'll mess it up. So right now, it's actually sensing, okay, but I'm not scanning just yet. I'm gonna start scanning in a second. Okay, here we go. We're having a bit of fun, right? Okay, here we go. Okay, hold on, hang on. Actually, I'm just going to watch it from here. Stay very still. Hang in there. There we go. Okay. Now this thing's going to ring. Okay. Very good. So thank you very much. Okay, you guys can sit down. Excellent. Thank you very much. Okay, so now this looks a little funny because what happens is I've just captured the color information and model separately. So actually what it's done is normally they would just catch points, but it's actually fusing a meshed model together. So what I'm going to do is I'm just going to shut off the color. Okay, so you get a sense of what this is. And let me see if I can minimize this a bit, make it clear. But I'll move this forward, and you can see that I can rotate this around, right? So it's a 3D model. So if you think about how powerful this might be at a crime scene, if you walk in, or police, the first responders get there, they can take a sensor like that and walk in and all of a sudden start documenting and recording the scene. So before they've disturbed anything, this is non-contact, right? They don't have to touch anything. They can stand off at a distance, they walk in, they start scanning around, so before they disturb anything, they've locked away that scene the way it is. I think that this type of technology, as we get higher quality sensors and such, I think this is going to start to have a big impact on crime scene documentation. Wrong one. Hold on. Back to my presentation here. Sorry. There we go. Okay, now I want to talk about these guys here. So these guys here are terrestrial laser scanners. And this one here is very similar to the one that we were talking about in the presentations before. So how do these things work? Okay, so it works on infrared light. Okay, it's an infrared laser. So on this side there's a laser, and it might be difficult to see, but I'll rotate it slowly, but there's actually a little window on this side. Okay? And the laser comes out, and it hits this mirror. And this mirror, you can see it's cut at 45 degrees. I don't know if you guys can see that. Well, that mirror spins. So what you have is the laser coming out, hitting a mirror at 45, and it's doing this. It's going to start doing this. But at the same time, this unit is going to start turning around. So you get this winding motion sort of spinning all the way around. And it can't scan underneath itself. It can't see underneath itself. It's got these little angled areas over here. Okay, so what I'm going to do is I'm going to do a very quick scan here, okay? And I'm just to show you what it looks like. And normally it beeps and makes noise and stuff, and I just shut it off. But you'll get an idea of what it does. So, and now I was jumping through all kinds of stuff here. Sorry about that. All right, so security pre-planning. This is where the scanners can be very, very useful. Let's say, for example, you are in a place where you're going to have somebody very, very important. And somebody who needs a lot of security, so like Rob Ford, right? Let's say he was here. Well, before he came here, he's going to say, well, I got to scope out this place because I never know who's going to be here. So this is a scan. I was here last week, so I actually did a scan of the auditorium here, and you can see nobody's here. But this is what it looks like to you or actually this is what I'm seeing when I'm looking at you. And I can go to different positions here. And you can see I'll move around. And now this is what the guy up there is seeing when he looks at me down here. So I can go to different viewpoints here. And this is what's called a point cloud. So again, it's millions and millions of points. This particular scanner can capture, again, up to about 1 million points a second. And as was said before, you'll never use it at that resolution because there's just so much data. But an average setting that I would use for an accident scene or a crime scene, in about 7-8 minutes, or 10 minutes, you're going to capture about 40 million points. So you multiply that by 20 scans, 30, 40, 50 scans, and you're up to 1 billion points in no time at all. So there's a lot of horsepower you need when you're processing this thing. Now, I'm looking at this from the inside, but I can also look at it from the outside. So I can go to the outside. Right? And there's a number of things you can do with this from a security standpoint, because you can look at, egress issues, cut off this, we can cut off the roof there and have a look. So it's a very, very powerful tool for documenting crime scenes, right? And security pre-planning. Okay, let me get back to it here. Okay, accident reconstruction. So very, very useful tool. In the past, they were using total stations, so single point measurements. Now what's happening is people are going out and police departments are going out and they're scanning with, they're capturing millions and millions of points with these laser scanners. So this is actually from a colleague of mine in the UK, and he sent me this set of scans. And so what we have is there's 2 vehicles down here, these 2 over here that have sort of hit and crashed, and these are their final rest positions. Well, so what can you do with this kind of thing? Well, you can segment those vehicles out, and you can stick them back together, right? looking at their impact locations, if I look at this from a top-down view, they have a very unique position where they fit together just perfectly. And so this, again, is very, very telling about who hit who, where, and how. And being able to look at it in 3D is very powerful. And you can also take something like a vehicle that's been crushed and then take an exemplar vehicle, put the two together, and then do what's called a deviation analysis. You can say, how far has something moved from a reference point or something like that? And so again, you're looking at something in another way that can be very, very useful depending on what that is. And this technique can be used for a lot of different techniques in forensic investigations. Roadway documentation. So if you want to map out the whole road and you want to go a kilometer, you want to go more than that, there's different types of scanning systems. There's mobile systems that you just drive and it scans. So if you want to do 30 kilometers, you can do 30 kilometers. So, and you see you pick up a lot of detail. In the case where there's, for example, roadway issues. So here we got the edge of a pavement, and you can see there's like a drop-off, and there's tire marks here. So this is actually around a bend, and vehicles they're dropping off the edge as they go around, and then there's soft gravel on the edge, and they're getting caught. And you can see scrape marks, right? You can see scrape marks off the side here. So you can pick up a lot of detail from these laser scans. Crime scene scanning. So this is an exercise that we did at the University of Toronto with some students just a couple of weeks ago. And what I'm going to show you is this is another way that you can present this. One of the benefits of laser scanning is that it captures panoramic images. Okay, so this is actually another way to look at this crime scene. What you're looking at up here are all the different scan positions that I've taken, and I can click on any one of them and bring up the panorama. Okay, so it's like looking at the scene from a different perspective without having to actually look at the point data, at the point cloud. So I'll click on another one, and so here we got another position, and I'll click on this one here. And so now I'm closer, and there's this dummy on the floor here. I've got a knife, and so you've got a piece of evidence. And you can use this as a documentation tool. You double click, it's a knife here or whatever, and I'll just, pops up a piece of evidence or something like that. So it's a really interesting way that you can present this, and this is something you can put on like a USB key and just hand over to somebody. So from a documentation standpoint, it's a nice way to present something in court. Okay, I'm going to do this one case, and then I'm going to be done. This is a case that I worked on recently. Actually, I just went to testify on it maybe a couple of months ago, and this is outside of Atlanta. And it's a case where there was some undercover police following a woman, actually, who was a suspect, and she happened to be talking to somebody who then became a person of interest, but was completely unrelated to anything she had been doing. And so what you're going to see here is that these are undercover, they're not in police uniform, whatever. They jump out of this SUV. You're going to see a vehicle moving back. They come out, and they've got their guns drawn. This guy thinks he's getting robbed. He pulls back, and they fire one shot, they fire a second shot, and he drives on. So this will probably play again, so I'll let it go again. But what I was asked to do was, we've got this security video, what can we do with it? Like, can you produce something from this? And so I said, yeah, I think I can, so let me have a look at it. And what we did was, I actually went down to the gas station where this was taken. We did a 3D survey of the gas station, and then we combined this with some other things. And I probably don't have time to explain the whole thing. But what I will do is just show you the work product. If it's going to just come up here in a second, I hope. Yeah. It's just thinking about it. And basically what we did was we combined some different technologies. So using photogrammetry and camera matching and using the 3D points, what you're looking at now is a view through the camera. So you're looking through the security camera now, and behind it, I've modeled, or actually I did this in conjunction with a colleague of mine called David Dustin out of Atlanta. And so working on this together, we've modeled some the pumps and stuff. So the security video lines up in the proper perspective to the 3D model. So now that we have it lined up, we can put in characters. Okay, these characters are these individuals, and look at their positions. And I'm going to cycle through the different frames of the video here. Okay, I'll go through that again. Now, one of the other things that you can do once you have it rendered out like this in 3D is you can leave the camera's position. So now what I'm going to do is I'm going to leave and I'm going to go through and we can look at these positions from someplace else. And this is just like a video game now. Okay? We can go through, we can look at this. Right? We can cycle through, we can look at the trajectories and the angles that it makes with the vehicle. We can do things like this where you have a rotating view, the vehicle's going back. And so, I had used this as part of my testimony in court, and it was very, very compelling, very compelling. So I'm going to leave it at that because I know I'm going to be running out of time. But I'm sorry if I had to speed up and talk kind of fast. But anyway, I hope I've given you a little bit of a picture, a little bit of a glimpse into how technology, forensic technologies and scanning technologies, and even what some of the analysis and techniques are that can be used in forensic investigations. Thank you.